so if you go back and look at the structure of all the triacylglycerols, the triglycerides, and the phospholipids, you can see why they are put in the category of saponifiable lipids. They all have ester bonds. So long as you have an ester bond, you can do a saponification. The next category of lipids, the sterols, they all have one thing in common. Actually, two things in common. They all have a steroid nucleus, which I'll show you on the board, and they all are non-saponifiable. The steroid nucleus looks like this. It's basically two hexagons like this, and then a hexagon like this, and then a pentagon. So this is called the steroid nucleus. So all the sterols are all in this category. They all have this. And can you see that you don't see any ester bonds? You don't see a carbonyl O anywhere. So they're non-saponifiable. You can't make soap out of these lipids, but they are definitely lipids. They're of biological origin. They are very nonpolar, okay, only soluble in nonpolar solvents. Cholesterol is the most abundant steroid in your body, and it is used as a precursor for a lot of the other steroid things. The term cholesterol, notice it ends with an OL. Do you remember that? What OL, things that end with OL, what are they? They're alcohols, exactly. Cholesterol's got an OH group right over here, and that's where the OL comes from. What are some functions of cholesterol? I remember many, many years ago when I was teaching, I think I was teaching a bio class at the time, and I said, what do you guys think our body uses cholesterol for? And a student raised their hand and said, to clog your arteries. Obviously, cholesterol is used for very many important things. It's not there just to clog your arteries. You don't want that. One of the key things cholesterol is for, it's for structure of the plasma membranes, plasma cell membranes. Remember we said that the phospholipids are super important in the structure of the cell membranes. Phospholipids are what give the membrane some fluidity. Cholesterol is inserted there to give it a little bit of rigidity. So that's one thing. Number two, it's an important precursor to synthesize bile acids. In fact, if you get cholesterol and you oxidize it, you're going to be turning it into bile acids. You've all heard of bile, maybe. Bile is produced by the liver, and then it's stored in the gallbladder, and then the gallbladder pours it into your small intestines to emulsify the lipids that you consume in your diet. So cholesterol is needed to make bile. The other thing cholesterol is important for, it is a precursor for all the steroid hormones, all the steroid hormones. So we're talking estrogen, progesterone, testosterone, all of those are steroid hormones. You can't make them unless you begin with the cholesterol nucleus and move forward. So that's that. And then number 4, we'll put that over here, vitamin D. Vitamin D is a fat-soluble vitamin. We're going to be talking about vitamins later on in the semester, but vitamin D, you've heard of it as the sunlight or sunshine vitamin. So if you're out in the sun and the sun hits your skin, you need cholesterol there so that cholesterol is a precursor to the beginning part of vitamin D, and then it gets activated in the liver and kidneys and becomes vitamin D. So these are some important functions of cholesterol. All you guys need to know is also structure-wise, because I think you've dealt with enough structures, just know that all these things have this general steroid nucleus. You don't need to know the details of how many carbons are coming out here, how many double bonds, OH. Just know that it's got to have 3 hexagon rings and 1 pentagon, and that is the general structure for all the steroids. Okay, so I know the function and structure of cholesterol, so that's the general steroid structure. You don't need to know any more details besides like that. And we are all set with the lipids chapter, and the next chapter will be proteins. Yay!